All right, welcome back. Today we're going to prove two more trigonometric identities, and the first one on top is quite simple. It's not going to take us long to do this one. The bottom one is a little bit more involved, and if we have time I may show you how to do this one two different ways. But like in the last video, we talked about starting with the side that is more complicated. We're definitely going to start with the left side on the top identity. Now before we do this, I want to remind you guys of an algebra trick. If you have 8 plus 4 divided by 2, you can, well, first off, what is the value of this? If we add 8 and 4, we end up with 12 divided by 2, which is 6. So we agree that this has a value of 6. Is there another way that we can arrive at a value of 6? The answer is yes. If I have 8 plus 4 divided by 2, I can split the addition in the numerator and write this as 8 over 2 plus 4 divided by 2. Notice that the 2 goes underneath each one of these. 8 divided by 2 is 4, 4 divided by 2 is 2. We add these, we get 6. So we see that this works. Be careful, do not make this mistake. 8 plus 4 divided by 2. You are not allowed to cancel the 2 with the 8, and you are not allowed to cancel the 2 with the 4 because the addition locks up the terms in the numerator. Meaning that, well, let me show you. If you cancel 2 with 8 and get 4, then this would give you 4 plus 4 over 1, which is not the correct answer. This is completely wrong. If you try to cancel the 2 with the 4 and you get a 2 up top, then you would have 8 plus 2, which is 10. Again, the wrong answer. This is not correct. Now, but how does canceling work when there is addition in the numerator? There is another way to do this. If you have 8 plus 4 divided by 2, cancellation takes place when there's multiplication. So notice that the 2 has multiplication next to it. If you don't believe it, well, that's 2 times 1 times 1 times 1. There's multiplication next to the 2. So the 2 wants to cancel. Multiplication allows things to cancel. But the 8 and the 4 are locked up because of the addition. The addition locks up both terms to left and right, keeping them from canceling. But we've learned in this class how to factor. And factoring creates multiplication. So why is factoring useful? Well, it's useful for many reasons. One of the most important things it allows us to do is to cancel when we have complex fractions. Notice that if I have 8 plus 4 divided by 2, what number divides 8 and 4? And this trick is going to be used on other types of trigonometric proofs. So what number divides 8 and 4? That is 2. So I can write this as 2 times 4 plus 2. Notice if I distribute over 2, notice if I distribute the 2, 2 times 4 is 8, and 2 times 2 is 4, so this is the same expression that we have up top. And notice what we've done is we've isolated this outer 2 with multiplication next to it, allowing it to cancel with the bottom 2, giving us 4 plus 2 is 6. So anyway, just wanted to mention this. The trick that you're going to need to use today is simply this. If you have addition, 8 plus 4 divided by 2, you would write this as 8 over 2 plus 4 over 2, giving you 4 plus 2, which is 6. All right, so we can do the same thing with this. Notice it's a similar form. There's addition in the numerator. Again, we're going to write our left side, secant squared of theta minus 1 over the secant squared of theta. And I told you guys to immediately convert to sine and cosine, but we're just going to hold off on that for a minute and use this trick to split the fraction, okay? It's going to make the problem a lot easier. Notice that we can write this as, there are 2 terms in the numerator. We can write this as secant squared of theta over the denominator secant squared theta minus 1 over the secant squared of theta, where we put the secant squared of theta underneath each term in the numerator, just like we put the 2 underneath the 8 and the 4. Now notice that secant squared of theta divided by secant squared of theta is 1. So we end up with 1. And on this, let's just write it like this, over 1 over secant squared of theta. Now at this point, again, if you look at where you're trying to go to a sine or a cosine form. This is the point in which you want to convert the secant squared to a cosine form. Okay, so we know that the secant of theta is equal to 1 over the cosine of theta. This means that secant squared of theta is equal to 1 over the cosine of theta. Oops. 1 over the cosine squared of theta. So if we have secant theta, that's cosine, 1 over cosine. If we have secant squared, that's 1 over cosine squared. So then we can write this as 1 minus 1 over, replacing secant squared theta with its form 1 over cosine squared. We end up with 1 over cosine squared of theta. And reminding you that when we have a number divided by a fraction, we flip the fraction and multiply. For instance, if I have 1 divided by 2/3, this is the same as 1, the top, multiplied by the reciprocal of the bottom, 3 over 2, which gives us 3/2. We can do the same thing here. We're going to first rewrite the left part of this expression, 1 minus, now pay attention to this. This is going to be 1 multiplied by the reciprocal cosine squared theta. And we're going to multiply this first, giving us 1 minus 1 times cosine squared is just cosine squared of theta. And again, look at where you're trying to go. You're trying to go to a sine squared of theta. And remember that the identity, whenever you're dealing with squared forms, you're thinking in your mind Pythagorean identities. What is the primary Pythagorean identity that we know? We know that the sine squared of theta plus the cosine squared of theta is equal to 1. And again, I've told you that you're proving things that are already true. So this has to work. Okay? Well, I'm not asking you to prove things that are false. So this form, 1 minus cosine squared, must be the same as the sine squared. And whenever you're dealing with cosine squared, you can convert it to a sine squared using the Pythagorean identity. And similarly, you can convert from a sine squared to a cosine squared. You cannot convert from sine to cosine directly, but you can do it in a squared form. Notice up here, we want to somehow create the expression 1 minus cosine squared. So if I take the cosine squared, can I move it to the other side of the equation? The answer is yes. We end up with sine squared of theta is equal to 1 minus cosine squared of theta. And from this we see, 1 minus cosine squared is sine squared, and the proof is done. Okay? So we have now shown, again, that the left side of this is equal to the right side through algebraic manipulation. Okay? Again, secant squared theta minus 1 over secant squared of theta is equal to this, which 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 is equal to the sine squared. Therefore, it must be the case that the left is the right. You have to follow this left-to-right format. Now, on the second question, it can be argued that the left side is more complicated than the right, or it could be argued that the right side is more complicated than the left. I'm going to show you a new algebra trick. We're going to start with the right side, because I want you guys to learn, again, this is advanced algebra trigonometry. I want you to learn an advanced algebra trick to turn this into this form. Okay? It's easier to go from left to right. It's harder to go from right to left here, but I'm going to choose the harder method so that you guys learn a new algebra trick. Okay? So we're going to start with the cosine of x over 1 minus the sine of x. And what we are going to notice is that there is addition in the denominator. You cannot split that. For instance, if I have 8 over 2 plus 2, notice on this problem we split the addition in the numerator. You're allowed to do that. You cannot split addition in the denominator. What is the correct answer to this? Well, 8 divided by 4 is 2. So we understand that this expression has a value of 2, 8 over 2 plus 2. But if you try to split the addition in the denominator and write this as 8 over 2 plus 8 over 2 and get 4 plus 4, you're getting the wrong answer. So this does not work. So you're stuck at this point. How do we get rid of that addition in the denominator and separate this fraction into 2 parts? Because we want to get to a 2-part form at the end. And the trick is this. It's called multiplying by the conjugate. This is one of the most powerful algebra tricks. Multiply by the conjugate of the denominator. And what is a conjugate? Well, a conjugate means opposite middle sign. So if I were to give you this, 5 plus 3, what would its conjugate be? Its conjugate would be 5 minus 3. If I'm looking at 4 minus 2I root 3. Its conjugate would be opposite middle sign. We don't change the front sign. It would be 4 plus 2I root 3. So what we're going to do here is we're going to multiply this fraction's denominator by its conjugate. And remember that, again, conjugate means opposite middle sign. We're not going to change the sign of the 1. It's going to be 1 plus sine of x. And I want you guys to try this on the homework. And if we multiply the denominator by this, we have to also multiply the numerator by this, okay? Now, we're now going to take the top and we're going to distribute the cosine x. Again, this is multiplication, so we have a monomial multiplied by a binomial. Cosine x times 1 is cosine of x, and cosine of x times sine of x is sine x cosine x, or if you want, you could write it as cosine x sine x, commutativity of multiplication. And on the bottom, we're going to FOIL this. 1 times 1, this is a binomial times a binomial, so 1 times 1 is 1. 1 times sine x is sine x. Negative sine x times 1 is negative sine x. And negative sine x times positive sine x is negative sine squared x. And notice that the sine x and the negative sine x, this is addition, they cancel each other out, giving us cosine of x plus sine x cosine x over 1 minus sine squared of x. Okay. All right, so where are we headed? Well, we're headed to a secant x plus tangent x, so it might help at this point to go ahead and run to the end of the equality string. Again, put an equal, equal, equal. It's going to keep doing this until eventually we arrive at secant of x plus tangent of x. And again, we've talked about the roadmap. Moving this backwards a couple steps will kind of help you see how to get these to connect. So to move it backwards, notice that we have sines and cosines in our problem over here, and we want to take the secant x and the tangent x and convert it back to a sine and cosine form. So what is secant x? Well, secant x is 1 over cosine of x plus, and we know that tangent of x is sine x over cosine of x. And notice that both of these have a common denominator, so we can add them together. When you add fractions with the common denominator does not change. So if we back this up one more step, the common denominator is cosine of x, and we add the top, 1 plus sine x. Okay, so this kind of helps us see, all right, if we're looking at this form, and it has to somehow get to this form, notice that we have a cosine x in the denominator here, but in our form back here, we have a sine squared, and we just did a problem. Again, when you have squared forms, you can convert between sine and cosine when the form is squared. Again, using what? The Pythagorean identity, sine squared of theta plus cosine squared of theta is equal to 1. And you can take the 1 minus sine squared and convert it to a cosine squared, because you can take, and we know this to be true, you can take the sine squared and move it to the other side, giving us cosine squared of theta is equal to 1 minus sine squared of theta. So we see that 1 minus sine squared of theta is cosine squared, so now we're going to take this and move it forward. We're going to have cosine of x plus sine x cosine of x over cosine squared of x. And we're very, very close now. And here you guys are going to have to see a factoring step. Notice that you have two terms up top. You have the cosine of x, and then you have the sine x times the cosine of x. You can factor out a cosine of x out of this binomial. If you take a cosine of x out, oh, this brings back what I talked about in the beginning. Remember, with the 8 plus 4 divided by 2, we could not cancel the 2 with the 8. We could not cancel the 2 with the 4 because the addition locked the terms up. You cannot cancel the cosine squared with the cosine of x because the addition locks up the cosine of x, and the addition also locks up the entire product to the right. So in order for you to allow cancellation to take place, you have to take out what's common among both of these terms. So what can you divide out of 8 and 4? You can divide out a 2. And what's left? Well, 8 divided by 2 is 4. 4 divided by 2 is 2. And notice now you can cancel your 2's. So we're going to do the same thing here. Notice that in both of these products, we have a cosine of x. We can take a cosine of x out, and this leaves us with, on the first term, if we took the whole thing out, that leaves us with a 1 plus. On the second term, we took a cosine out, that leaves us with a sine of x over cosine squared of x. And now you see that we can cancel the cosine of x with the cosine squared of x. Remember that cosine squared is cosine of x times cosine of x. So basically you're canceling a cosine with a cosine. And notice this leaves you with the 1 plus sine x over the cosine x, which is equal to this, which is equal to this, which is equal to the final form, and you guys are done with the problem. All right, you guys have a wonderful day, and I'll send you the homework in a minute.